Hi chemists, my name is Kim and today we are going to be talking about amines and amides, two functional groups that can be found in organic molecules. So our learning goals for today, we are going to learn how to identify whether or not an organic compound could be classified as an amine or an amide based on its chemical formula, its structural formula, or its name. And we will learn how to, if we are given a structural formula, identify what the name of that particular compound would be. So you'll need your New York State reference table with table R if you are using this to prepare for the New York State Regents exam. Otherwise, you'll need whatever reference table you are using to determine functional groups, and we will get going. If we look at our reference table, at table R, we can find our information about the organic functional groups amines and amides down at the very bottom. Notice the major difference between these two groups is just whether or not there is an oxygen as well as a nitrogen atom involved in the compound. In an amine, there is just a nitrogen atom. In an amide, there is a carboxyl group, that's the carbon double bonded to the oxygen, that is also bonded to the nitrogen. Get into a little bit more detail and look at some naming examples. So for amines, the functional group is a nitrogen atom in the carbon chain. Now, that nitrogen atom could be in the middle of the carbon chain, it could be at the end of a carbon chain, it can be anywhere in the carbon chain. The nitrogen atom could be bonded to 2 carbons, 1 carbon, it doesn't matter. It can still be an amine. The key here is that there is just a nitrogen atom coming off of the chain, and then often that nitrogen atom will be bonded to 2 hydrogens, but not always. It could be bonded to other carbon atoms as well. To name an amine, we are going to count the number of carbons in the parent chain so that the nitrogen is numbered on the smallest number possible. So this is really similar to when we were naming branched alkanes, if you remember that video. So we're counting the number of carbons in that chain. We're naming the parent chain as if it was an alkane using table P. And then we are using the number of that the N branches off of to put as a number at the beginning of the name. So we'll put a number at the start of our name and then put a dash. We're going to take our parent chain name and remove the E at the end and add amine at the end as the suffix. So the number dash prefix almost sounds like you're saying the beginning of an alkane name, and then amine is what tells you that you have an amine. So we're going to look at the example that's given and think about that. Let's take a look at the example given to us in table R for an amine group. So table R is showing us 1 propanamine. Notice the format of this naming convention. The 1 is telling us the number that the nitrogen is coming off of the carbon in the parent chain, while the prop is telling us the name of the alkane. So it's telling us the number of carbons that are in that parent chain. The amine at the end is just telling us that there is an amine group, that there is a nitrogen bonded to 2 other things. So prop is telling us that there are 3 carbons in that carbon chain. So if I was going to visualize what this structure would look like, there's 3 carbons there. This would be 1 propanamine, because if I am looking at my carbons and I am numbering them so that the carbon that is closest, that the nitrogen is coming off of is the lowest number, I should be numbering them from right to left. So 1, 2, 3, like that. Now let's consider our next functional group, amides. They're very similar to amines in that they have nitrogen atoms, but in an amide, as I mentioned before, we have a carbon double bonded to an oxygen that is then bonded to a nitrogen atom. That's known as a carbonyl carbon. That nitrogen atom can then be bonded to 1 hydrogen, and it can actually be in the middle of a carbon chain and continue bonding to a more complex molecule, but we're only going to talk about naming a amide if it is the terminal end of the carbon chain when we have it. So the nitrogen is bonded to 2 hydrogens is going to be the type of naming that we will do. To name a amide that has the nitrogen at the end of one of the chains, it's pretty straightforward. We count the number of carbons in the chain. We don't have to worry about which direction we are counting it from. And we name the parent chain as if it was an alkane using table P. we would remove the E at the end and add amide as the suffix. So that tells us that we do in fact have an amide. There's no number necessary because we are not counting the number of carbon that the nitrogen is coming off of. If, just so you know, if we did have a more complicated molecule where the nitrogen was then bonded to another carbon, we would name this in a very similar way to how we name esters, where we would go and take the shorter carbon chain and make it into a prefix. But that's a little bit out of the scope of the type of questions that you would probably see on a Regents exam, but it's of the same pattern as naming esters. Let's look at an example naming our amide that's in table R, propanamide, or propanamide. You'll hear people pronouncing organic molecules different ways. Propanamide, remember the only thing we really care about after we see the amide at the end or the amide at the end, that's telling us that we have an amide group. That's going to tell us that that propan is just telling us about the number of carbons that are in the carbon chain before the nitrogen is bonded. So there are 3 carbons, because prop means 3, including the carbonyl carbon, including the carbon that's double bonded to the oxygen. So I've got 1, 2, 3 carbons, including the carbonyl carbon, and then coming off of the carbonyl carbon, or the carbon that's double bonded to the oxygen, I then have NH2. So this would be propane as my carbon chain parent chain. I would take off the E at the end and just add amide at the end, so propanamide. Let's do a couple of practice questions. So, using table R, which functional group contains a nitrogen atom and an oxygen atom? Is it an ester, an ether, an amide, or an amine? If we're talking about both a nitrogen and an oxygen atom, this would be an amide or an amide group. So not an amine, because an amine group has a nitrogen but no oxygen. Not an ester, because an ester has a carbon double bonded to an oxygen, but then it's bonded to an oxygen, not a nitrogen. And not an ether, because an ether doesn't have a carbon double bonded to an oxygen, and it doesn't have a nitrogen atom. Let's try this one. Given the formula for a compound, so here's the structural formula of a compound, what would the chemical name for this compound be? Make sure you're using table R. You can use my tiny little screenshot on the screen, or you can use your own version of table R to help you find the name. So let's take a look at this compound in a little bit more detail. I see a nitrogen, so I know automatically that I must either have an amine or an amide, but I don't see a carbon double bonded to an oxygen. I don't see that carbonyl group. So that tells me that I don't have an amide. So 1 and 2, which all end in amide, are eliminated. It's either going to be 1 butanamine or 1 butanamine, or 4-butanamine, 1-butanamine or 4-butanamine. So I can think about this 2 different ways. I could either count my carbons from left to right, 1, 2, 3, 4. That means the nitrogen would be coming off of the 4th carbon, or I can count from right to left, 1, 2, 3, 4. That puts my nitrogen off the 1st carbon. I want to name it so that the nitrogen is on the smallest possible carbon. So because 1-butanamine and 4-butanamine are actually saying the same thing, right, that nitrogen is on the end, 4-butanamine is actually not a valid name. That would only ever be called 1-butanamine, because you could just switch the way you're naming, switch the direction that you're numbering your carbons in. So my answer here would be 3. What is the name of the compound with the formula CH3, CH2, CH2, NH2? So again, using table R to help you think about this. This one is a little bit tricky because they're giving me a condensed formula where they're writing CH3, CH2. That means that there's 3 hydrogens around my first carbon, 2 hydrogens around my second carbon, 2 hydrogens around my third carbon, and then a nitrogen that's coming off of that carbon with 2 hydrogens bonded to that nitrogen. Looking at the table, looking at table R, this originally seems kind of difficult, but actually this compound matches exactly what is written down for the amine group. I've got 1, 2, 3 carbons, one with 3 hydrogens off of it, and then 2 with 2 hydrogens, and then a nitrogen with 2 hydrogens. This is 1 propanamine. This is the same exact example that's given in the table. I could figure this out otherwise because if you look, again, there's no oxygen found in this compound. So it can't be an amide, but it's got nitrogen in it. So the only thing left for it to be would be an amine. So it would be named 1-propanamine because, again, we would want to name it so that the nitrogen was on the smallest possible carbon. So we would think about the nitrogens coming off of one of the ends. So we would name it 1-propanamine. Given the formula for a compound, what is the chemical name for the compound? This compound does have both a carbonyl carbon, that's the carbon double bonded to an oxygen, as well as a nitrogen. That tells me this must be an amide. And so if I look at my naming options, 1 says amine at the end, so it can't be that. 2, 1-butanol, that would be an alcohol, so that's not right. 4, butanoic acid, that would be an organic acid, so that's not right. The answer's got to be butanamide. We've got 4 carbons, so that makes it butane. Drop the E at the end and add amide at the end as a representative of the functional group. Let's recap our learning goals. Hopefully you feel comfortable and confident to identify whether or not an organic compound is an amine or an amide, looking at its formula or its structural formula. And you are comfortable going from the structure of the compound to its name and vice versa. Nice job today.